Okay. If we have a couple of really simple things, like just two separate elements, and we're going to combine them, we're going to run some kind of reaction that combines these two elements into a compound. First of all, we've got to know their symbols. So you look up indium, look up the element indium. Just the letter I is iodine. You should have out your test references so you can practice with those during this class. Mm-hmm. Yep. Mm-hmm. So indium is In. Now, listen. An element that is by itself, uncombined, whether it's combined with itself 8 times like this, or indium, the metal that you don't combine with anything when you write it, it has a 0 charge. Okay? So it has no oxidation number. You can think of this as having a 0 oxidation number. Since it's just indium metal, and haven't yet combined it. Okay? Once we combine it, it's going to have a charge. It's got an oxidation number, but over here it has no oxidation number. It's just indium the metal. Okay? What physical state is indium going to be in? It's a metal. It's a solid. Sure. There's only one liquid metal. Y'all know what that? Well, actually, there are two. There's only one common liquid metal. You know what it's called? Mercury is the only. Mercury is the only liquid metal. Well, it's not. Water's a compound. Okay. Let's see. They used to call mercury quicksilver. So we're going to put it together with this sulfur. Okay. And you don't have to know this, but it happens to be solid. I just figured you'd know metals were solid.
Well, that's common sense.
Well, for most people, I think it'd be common sense, yeah. Well, I mean, some people don't think it through. You know, it just goes past them. It's not a matter of, well, they call it common sense, but no, it's not IQ. There's some really smart people have a really high IQ that don't seem to have a lot of common sense.
Yeah, you can't have both.
Well, you can have both. All right. To put what kind of an element is indium? Huh? It is a metal. It's a transition metal, but it's a metal, right? And what kind of element is sulfur? A non-metal. So when we put those together, we're going to make what kind of compound? Ionic. Which means the indium and the sulfur, when we put them together, will have charges. Okay? So what charge are we going to assign to the indium? Okay, and where did you get that? What? The oxidation number on the periodic table with oxidation numbers. It's right here as a 3+ charge. Okay? And when we put them together, what charge are we going to assign to the sulfur? Negative? 2 negative. Now, I'm sorry, I don't know why I wrote that. It's just an S. Okay? Alright. So, if indium is plus and it only has one kind of oxidation number, it's a plus charge. To get a balanced compound, I have to have an equal number of plus and minus charges. Okay? So, since sulfur has all these different charge numbers, the only one we can use is the one that's negative. Because I've got to have an equal number of positive and negative charges. So we have to use the 2 negative. What I need is an equal, not an equal, but whatever number of these indiums I need, and whatever the number of these sulfurs I need to get the number of plus and minus charges to be the same. 2 and 3. 2 of these and 3 of these. 2 times 3 plus is 6 plus. 3 times 2 negative is 6 negative. That's an equal number of plus and minus charges. So when I put it together into a formula up here in our equation, that coefficient in front of the ion, when I bond it together, becomes a subscript. And the coefficient in front of this ion, when I put it together, becomes a subscript. And there's the formula. No, the 8 is only on this side of the equation. Alright, what we're going to do now that we figured out how to balance the formula is figure out how in the world do we get this whole thing to have the same number of atoms on both sides. And I gave you one that's purposeful. Alright? Now that we've got it, how do I get the number of atoms on this side? I got to get the number of sulfur atoms on both sides of this arrow to be the same. Add 5? We can't add. We can only put coefficients in front and multiply. Well, I could do it with an 8. 8 and a 3. That would fix it.
Why didn't you put it in front of
Well, you can only put, once you got a compound, you can only put the coefficient out in front.
So now you gotta put the 8 over there?
Yes, no, not an 8.
8, no.
16. There you go. So now I have 16 indiums on this side, 16 indiums on this side. 8 times 2. I've got 3 times 8 or 24 sulfurs on this side, and 8 times 3 or 24 sulfurs on that side. Okay? So balancing equations we're supposed to learn in physical science. I know this is review. Might be a long time ago, but you know, it's basically the same stuff. It's just algebra. Okay? Just written in a different way. Alright? And that's what we did for the post lab, that kind of work. Unit 4 is really just about making these compounds work out. Balancing equations was physical science. So it's all review. Okay? The next unit will be all about balancing equations. So this is kind of this lab we did, where you had to do this kind of thing, is a transition sort of lab between Unit 4 and 5. Okay, where we practice doing this because that's part of Unit 4, and the next unit we're going to be doing this, which you did in physical science. We're just going to do it to a higher level in chemistry. Okay?